Assalamualaikum and hi. We are Group 6 from DAT program taking the course Algebra and Calculus DAT11203. Let me introduce our group members. First one is Muhammad Faris Luqman bin Muhammad Taufik. Section 4 is me. The second one is Muhammad Shazza Afham bin Muhammad Shawwal. Section 4. Third one is Muhammad Shakir Akmal bin Norwan. Section 4. And last one is Adam Muhammad bin Muhammad Fazil. Section 1. In our video, we will be presenting our problem-based learning task, which is our problem is about air being pumped into a spherical balloon. In this experiment, air enters the balloon at a constant rate of 100 cm per second. The objective is we determine how fast the radius of the balloon increases when the radius reaches 10 cm. For part A, we are required to find the rate of change of the radius using related rates from calculus. For part B, we discuss why the radius increases more slowly as the balloon becomes larger. This happens because as the volume increases, a larger surface area must expand, so the same amount of air causes a smaller change in radius. Besides that, we focus on light intensity through a lens, which is modeled using a mathematical function. For part A, we need to determine the position where the light intensity is maximum. This involves using differentiation to find the critical point. For part B, we are required to plot the graph digitally and clearly mark the maximum point. This helps us visualize how light behaves through the lens. This step of problem is important in real-world applications such as camera lens, optical instruments, and image processing, where maximizing light intensity improves performance.
Alright, Assalamualaikum and hi everyone. Okay, today we are going to discuss about my questions. Alright, for question 6.1a, we are required to find the rate of change of the balloon radius when the radius is 10 centimeters. Okay, the information is given that air is pumped into the spherical balloons at a constant rate of 100 centimeters cubed per second. Alright, so how do we do it? We know that the volume formulas for sphere is V equals 4 per 3 pi r power 3. Alright. Next, we differentiate both sides with respect to time, related volume, and radius. Okay. After that, we substitute the given values where the radius equals 10 centimeters and the rate of change of volume equals 100. So 100 equals 4 pi 10 power 2 dr per dt. Okay, then we simplify the questions, so we get dr per dt equal 1 per 4 pi. Therefore, the rate of change of balloon radius is approximately 0.0796 centimeters per second. Alright, this means that when the balloon radius reaches 10 centimeters, the radius is increasing at a speed of 0.0796 centimeters every second. Alright.
Assalamualaikum and a very good morning to you. My name is Muhammad Shazza Afham bin Muhammad Shawwal, Noble Matrix AA 250813. I am from Group 6 and I have the duty of doing question 6.1, question B. The question is explains why the radius of the balloon increases more slowly as the balloon becomes larger. Even though air is pumped into the balloon at a constant rate, the balloon volumes become much bigger as the radius increases. From the formula, we can see that the radius r become larger. The value of 4 pi r to the power of 2 also becomes larger. As a result, the rate of change of the radius becomes smaller. This means the balloons expand slowly as it gets bigger. In engineering, This is important because engineers must choose materials that can stretch without it bursting, and they must also determine the maximum size of the balloon. That's all from me. To the next question.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syakir Kemal Penyerwan. I will explain question 6.2 part A. Okay, how to find the position at for maximum light intensity. The intensity function is given by this. So, to find the maximum intensity, we first differentiate the function with respect S, because the function will contain two terms multiplied together, which are 100x and e power negative x power 2. After differentiate, we obtain this, and to find maximum point, we must equal to 0. So we set this to equal 0, since 100 e power negative x power 2 can never be 0. We only solve this because lens position is taken as positive. We choose this. Therefore, the position for maximum light intensity is x equal to 0.707. After that, we substitute this value into the original equation to find the maximum intensity. So we get, for the maximum intensity obtained is 42.89. So the maximum point is 0.707 and 42.819. This means the light intensity reached is the highest value when the lens position is 0.707.
For this part, I plotted the graph of the function y equals 100 x e to the power of negative x square using decimals. From the graph, we can see that the light intensity increases at first as the value of x increases. This continues until it reaches the maximum point, which is approximately at 0.707, 42.89. At this point, the intensity is at its highest. After that, the graph starts to go down. This happens because of the exponential decay term e to the power of negative x squared, which becomes smaller as x increases. As a result, the overall value of y decreases. So, the graph shows that the light intensity increases to maximum, then decreases, forming a peak at that point.
Alright, next, I will explain the interpretation and discussion for this project. Okay, based on the result obtained, when the balloon radius is 10 centimeters, the radius increases at a rate of 0.0769 centimeters per second. This shows the balloons expand more slowly as it becomes larger. For the option problem, the maximum light intensity occurs when S equals 0.707, with the maximum intensity value of 42.89. Okay, from the graph, we can see that the balloon's expansion rate decreases because a larger balloons require more air to produce the same increase in radius. Alright, in other words, as the surface area becomes bigger, the expansion becomes slower. Okay. Meanwhile, for the light intensity graph, the intensity increases until it reaches the maximum point, then decrease due to the exponential decay effect. Okay, so overall, differentiation is a very important because it helps us determine the rate of change in real life engineering situations. Okay, it's allowed to analyze how fast a quantity change and also help identify maximum or minimum value in mathematical method. Alright.